Hi everyone, today we are going to learn about probability, but before we get started, I would like you to please go ahead and factor the following four expressions. The first expression is x to the fourth power minus 14x squared plus 45. The second one is x squared minus 36y squared. The third one is 3x squared plus 10x minus 8. And the final one is 8x to the third power minus 64y to the third power. I want you guys to look for opportunities to factor out a greatest common factor. Look for opportunities to use our shortcuts like difference of two squares and sum or difference of cubes. And when you have an answer, please go ahead and restart the video and we'll see how well you did. Okay, so for the first one, this is called quadratic form. And whenever you see something in quadratic form, that just means that you're going to factor it like a quadratic, but instead of splitting apart the x into our x squared into an x and an x, we're going to split apart the x to the fourth into an x squared and an x squared. Then we have to ask ourselves, what two numbers multiply to equal 45, put together add to equal negative 14, and that is a negative 5 and a negative 9. Well, x squared minus 9, that's a difference of two squares that I like to call dots. And so we have an x squared minus 5, and we'll split apart that difference of two squares into two more parentheses. We'll have an x plus 3 and an x minus 3. Next, we have x squared minus 36y squared. This is a difference of two squares as well. So I'm going to split that apart into two parentheses. Taking the square root of each term, I have an x and an x, a plus and a minus. And 36y squared, I'm going to take the square root of it, and we end up with 6y for each. So x plus 6y, x minus 6y. Next, we have 3x squared plus 10x minus 8. So I'm going to split apart the 3x squared into a 3x and an x, since that's the only way to get a 3x squared. And I'm going to work with the factors of 8 and ask myself, what numbers working with 3 can give me a 10? So thinking about that, I know whenever I think of 8, I always think of 4 and 2. And I know that 3 times 4 is 12, and 2 is 10 away from 12. So I think that I figured out my order. I think I want to multiply 3 times 4 and 2 times 1, because if I have 3 times 4, that's a 12x. And a 2 times x, that's a 2x. And if 2 was negative, that would give me a 10x. So I'm going to make the 2 negative and the 4 positive. And that is my answer. So we have 3 times x minus 2 times x plus 4. Next, for number 4, we have 8x cubed minus 64y cubed. Now, you probably already saw right away that this is a difference of cubes. So because this is a difference of cubes, then you probably started factoring it right away and making it a binomial times a trinomial. But there exists a greatest common factor, and the greatest common factor of 8 and 64 is an 8, and so you have to factor that out from the very beginning. You're going to end up with x cubed minus 8y cubed. Now this is also a difference of cubes as well, so we'll still continue factoring. So I'm going to make this an 8 on the outside of a binomial times a trinomial. In my binomial, I'm going to take the cube root of each term, so that's going to be an x and then a minus 2y. So I took the cube root of each term, and now I'm going to use this binomial to come up with my trinomial. That's where the square opposite product square comes in. I'm going to take my first term and square it, so I end up with x squared. O means opposite. The opposite of a minus is a plus. P means product. That means I'm going to multiply x times 2y, and I end up with 2xy. We typically put that in alphabetical order. And last is squared. So 2 times 2 is 4, so that's going to be plus 4y squared. And that is your answer. So hopefully you did pretty well with these factoring problems. Hopefully they were pretty easy for you. If they were not, please make sure that you have a conversation with me immediately, because factoring is still going to be on every single test, and I still want to make sure that you are prepared for seeing those problems on whatever test that is coming up. So our learning targets for today is for you to be able to say, I can identify the theoretical and experimental probability of an event occurring, and I can explain the difference between the two forms of probability. So there are a total of 3 different probabilities that we're going to be learning about. The first one is theoretical, the second one is experimental, and then the third one is called geometry or geometric probability. The next I can statement says, I can identify the odds in favor or odds against an event occurring. So a lot of times you'll hear in probability, what are the odds of something occurring? We're going to be identifying that in this lesson. And I also want you to be able to say, I can find the probability of hitting a target using geometry probability or geometric probability. And that is our third type of probability that we're going to be learning about. So there's a few vocabulary words that I want you to become familiar with when it comes to probability. And the first word is called an outcome. So an example of an outcome is the following. When you roll a standard six-sided die, the possible results are called outcomes. So we have outcomes being 1, 2, 3, 4, 5, or you can roll a 6. Those are all of your possible outcomes. There are a total of 6 outcomes if you roll a standard six-sided die. Now, an event is an outcome, like rolling a 1 or rolling a 2. Or it's a collection of outcomes. So an example of a collection of outcomes would be rolling an odd number. If you roll an odd number, that means that you want to roll a 1, a 3, or a 5. And if you roll a 1, 3, or 5, the chances of that happening is going to be 50%. 3 out of 6, which is 50%. All right, so probability. I just alluded to what probability is all about. The probability of an event is the measure of the likelihood or chance that an event will occur. And we have a number line to kind of explain what it is all about. So our number line that we have here starts at 0 and it ends at 1. 0 means like 0% chance that something would occur, and 1 means 100% chance that something would occur. The point 50 would mean that 50% chance that something would occur. So you can write probability as a fraction, a decimal, or a percent. Now, probability of 0 means that it is impossible, absolutely impossible. An example of something that's impossible is, what is the probability of rolling a six-sided die and ending up with a 7? That's impossible. There's no 7 on that die. So that would be an example of a probability of 0. Probability of 1 means that it absolutely will occur. An example would be, I'm going to roll a die. What is the probability that I roll a die and I end up with a 1, 2, 3, 4, 5, or 6? Well, that's 100% because you're going to end up with one of those numbers when you roll a die. 50-50 or something in the middle, well, that just means that it could happen, it might not happen. It's just going to be, it's a 50-50 shot. So anything that's in between 0 and 0.50 or 1/2 or 50%, that means that the event is more likely not to occur. So chances are it's not really going to happen. Versus an event that is more likely to occur, that it will take place, or the probability that an event that is more likely to occur, well, the probability that's in between 0.50 and 1. So which way do I want your answers for these types of problems? When it comes to probability, I would prefer your probability answers to be written as simplified fractions. So the preferred final answer should be simplified fractions. Sometimes it makes sense to have your answer be a decimal. Sometimes it makes sense for your answer to be a percent. It just depends on what is requested. If nothing is requested, then I am personally requesting simplified fractions because that kind of makes a little bit more sense with some of the problems that we're going to be working with. So the first type of probability that we're going to be learning about is theoretical probability. This means that if it happened in a perfect world, what would we expect to see? Meaning, like, if we flipped a coin, we would expect to see that 50% of the time will land on a head, and 50% of the time it will land on a tail. That's in a perfect world. But we don't live in a perfect world. That's where other probabilities come into play. But in theory, when all outcomes are equally likely, the theoretical probability that an event A will occur is the number of outcomes divided by the total number of outcomes. So the number of outcomes in event A divided by the total number of outcomes. So the probability that an event A will occur means what do you want to see happen divided by all of the possibilities of things that could happen. So the theoretical probability of an event is often simply called the probability of an event. So we don't really call it theoretical necessarily. You'll just see what's the probability of that happening. So like the probability of flipping a coin is 50-50. We would hope to see 50% of the time that you would land on a head or a tail. What's the probability of getting an even number or and the number 5, or an even number and the number 5? So that means that you would end up with 2, 4, 6, and 5 as possibilities. That's 4 out of 6. Things of that nature. Those are considered theoretical probabilities. So let's go ahead and look at an example, just so that we have a clear understanding of what theoretical probability is. It says you pick a card from a standard deck of 52 playing cards. Find the probability of A, picking an 8, and B, picking a red king. So picking an 8. So what we want will go on top out of the total that will go on the bottom. So we want an 8, the probability of getting an 8. So there are 4 8s in the entire deck, 1 for each suit. We have diamonds, hearts, clubs, and spades, 4 8s, out of a total of 52 playing cards. So what you want will go on top of the probability that that event will occur, or the number of outcomes for that event to occur will go on top, divided by your total number of outcomes. Now, because I want your answer to be written as a simplified fraction, and 4 and 52 both have in common a 4, I'm going to factor out a 4 or divide out a 4, and I end up with 1 over 13 is our answer. So the chances of you selecting an 8 after you've shuffled the cards and you go and have to pick a card, that's going to be 1 out of 13. What is the probability of picking a red card? Well, we have a red king, excuse me, not just a red card, a red king. So we have 4 kings. We have a diamond, heart, club, and spade, and 2 of them are red, a diamond and a heart. So because there are 2 kings that are red, 2 will go on top, divided by our total number of cards, and our total number of cards are 52. So 2 out of 52, since they're both even, we can divide them both by 2, and we end up with 1 out of 26. So 1 out of 26 chance of you selecting a red king. Let's go ahead and look at something a little bit more complicated, like example number 2. It says a talent agency conducts a talent show for local musicians on a given evening. 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. So what is the probability that the musicians perform in alphabetical order by their last name? Assuming, of course, that no 2 musicians have the same last name. So let's think about this. Alphabetical order means that we are going from A to Z, and there is only one way for that to occur, and that is alphabetical order. Think about your class rosters, putting everybody in alphabetical order in our class. There's only one way to do it. You start with your A's, you end with your Z's. So that's going to be one order of that possibly taking place, divided by the number of ways that 7 musicians can perform. Now this is where it gets a little bit tricky. The number of ways that 7 musicians can perform. Notice that I double underlined the word order. So think about it. In our first position, we have 7 possible musicians that could perform first. Once someone has performed, that means 6 more. There's 6 possibilities, or 6 other performers that could perform second. Once those 2 have performed, then we have 5 people that could perform, then 4, 3, 2, 1, and then you have your final person. So the last person would be your final performance, and only one person could provide that final performance. Well, 7 times 6 times 5 times 4 times 3 times 2 times 1, that's just 7 factorial. So I'm going to divide 1 divided by 7 factorial. That's the total number of ways that 7 musicians can perform. So you have to be careful and use, when it comes to your denominators especially, you're going to have to use your knowledge and skills from 10.1 and 10.2, as well as the fundamental counting principle. So it's very important that you recognize the language in which some of these problems are going to be, or you have to kind of recognize some of that language that we've used in the past to help us to kind of come up with our probabilities. So 7 factorial, that is 5,000, that's 5,040. And 1 out of 5,040 is approximately 0.0001984. So the likelihood that randomly the performers perform in alphabetical order is very unlikely to occur. And that's one of the nice things about the decimals, is that it tells you, or it gives you an idea of how likely something will occur. So that's like really a nice thing. But in terms of your answer, I only need to have your answer in fraction form. So that's all I'm going to be looking for. You use the decimal in order to identify the likelihood of something occurring, whether it's going to be very likely, kind of likely, or not likely at all. So, or very likely, whatever the case may be. Let's go ahead and look at letter B. It says you are friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? So the first part says identify the number of ways 2 performers are your friends. So identify the number of ways that you can select 2 of your friends to perform first. So that means out of your 4 friends, you're just going to choose 2 of them. You don't care which one goes first. They're both going to be your friends. That's what you want. Out of your 4 friends, you want 2 of them to go first. Divided by the number of ways that 2 performers can be chosen. So there are a total of 7 performers, and 2 of them are going to go in the first and second positions. So we're just going to select 2 at a time. So at this step, we're just going to put 4 choose 2 into your calculator, and when you do that, you end up with the number 6, divided by 4 choose 7, and when you put that into your calculator, you end up with over 21. So 6 over 21 can be simplified to 2/7. So your answer is 2/7. That's your probability. But if you wanted to identify what is the likelihood of that occurring and how likely would it occur, that's when you look at the decimal. And that decimal is going to be approximately 2.89. And 2.89, yeah, it's more likely than randomly having alphabetical order taking place, but it's still not likely to occur. It's not likely that both of your friends are going to, or 2 out of your 4 friends are going to perform back to back randomly. All right, so that is theoretical probability. All right, the next topic that we're going to talk about is odds. So odds is a little bit different. Odds is language that we've used throughout most of our lives. What's the odds of that happening? What are your odds? 3 to 1, 2 to 1, things of that nature. So odds, you can use odds to measure the likelihood that an event will occur. So it's like probability, but it's a little bit different. So this is, because it is different than a traditional probability, the way that our answers will be written will be different as well. And that's because we want to make sure that we have a distinction between what probability is versus what odds are. So the odds measure the chances in favor So it measures odds measure the chances in favor of an event occurring or the chances against an event occurring. So if you want in favor of, so when all outcomes are equally likely to occur, the odds in favor of an event and the odds against an event are defined as follows. So the first part says odds in favor. So the way I always remember odds in favor is whatever you want will go on top and whatever you don't want will go on bottom. So odds in favor is going to be the number of outcomes that you want divided by the number of outcomes you don't want. So whatever you don't want will go on the bottom, whatever you do want will go on top. And it's going to be the reciprocal for the odds against. So the odds against means what you don't want will go on top, and what you do want will go on the bottom. So it's going to be the reciprocal. So you kind of have to pay attention to the story problems and pay attention to if you want odds in favor or odds against. Now, there are two ways in order for you to write odds in favor or odds against. One way is a fraction, or you can write it as a ratio. The ratio is what we're looking for. So leave all answers. As simplified ratios. Why? Well, you're going to see the why in just a second. For example number 3, it says a marble is drawn from a bag containing 6 red, 12 yellow, and 9 black marbles. Find the odds in favor of drawing a red marble and the odds against drawing a black marble. Well, the odds in favor of drawing a red marble means that I want to have all of the number of red marbles be on top, and anything that is not red will go on bottom. So not red are going to be your yellow plus your black. Notice it's not all outcome. It's not red out of all total. We're not trying to find the probability of selecting a red. We're trying to find the odds in favor of getting a red. So that is different. If we wanted to find the probability of selecting a red, then we would take the number of red and divide it by the total number of marbles in the bag. But because we're working with odds, what we want goes on top, what we don't want goes on bottom. So we have 6 red, and that's going to go on top. 12 plus 9, 12 yellow plus 9 black will go on the bottom. So that's going to be 6 over 21, which is equal to 2 over 7. And we write our answers as ratios of 2 colon 7. And what this colon means is the word 2. This means 2 to 7. Those are my odds in favor of selecting a red. This is different language than what we had up here, where we were looking at the likelihood of your 2 friends being selected first to perform out of 7 performers. So this means 2 out of 7 chance of that occurring. This is different because you're not saying you have a 2 out of 7 chance of selecting a red. These are your odds, where you have in favor of what you want, dividing out what you don't want. It's completely different in terms of its meaning. So that's the reason why we write our answers as ratios. Let's go ahead and look at letter B. For letter B, we have the odds against drawing a black. So we want black to be on the bottom, because what we want goes on the bottom, and what we don't want, what's against black, will go on top. So what's against black is going to be red plus yellow. So red is 6, yellow is 12, so we have 6 plus 12 on top, and black is 9, that'll go on the bottom. 6 plus 12 is 18, 18 over 9. Don't just write this as the number 2. Write it as 2 over 1, and then change it to a ratio, making it 2 to 1. If you are worried about messing up this process and you want to just work with ratios from the very beginning, that is absolutely not a problem. and it might even be helpful and beneficial for you to do that. But that's how we identify odds in favor and odds against. Let's go ahead and look at our next type of probability, and that's called experimental probability. Sometimes in probability, you cannot calculate the theoretical probability of an event. In these cases, you may be able to find the experimental probability by performing an experiment or conducting a survey or looking at the history of an event. It's by actually doing something is what experimental probability actually is. It's like living in the real world. When you flip a coin, 50% of the time you won't get a head, and then 50% of the time you get a tail. It just doesn't happen that way. Instead, whenever you flip a coin, you might get a whole string of heads, and then a whole string of tails, and then a head and a tail. And that's just what happens. And so this is living in the real world. Because this is probability, we would still write our answers as simplified fractions. So when an experiment is performed that consists of a certain number of trials, the experimental probability of an event A is given by the probability of A equals the number of trials where A occurred divided by the total number of trials. For all of these formulas that I've talked about so far, I need you guys to please make sure that you know and study all of them. Know and study all of anything that deals with odds. Know and study your theoretical probability. So I'm going to make sure that I identify that. So I'm going to write know and study. Keep everything straight. When are you dividing by the total number of outcomes? When are you dividing by what you want versus what you don't want? So I want you to please make sure that you know and study all of these. Keep track of all of your formulas. That's some of the toughest things that you can, it's a tough thing for a lot of kids to do in this section or in this chapter. All right, let's go ahead and look at example number 4. It says exam grades of students in a history class are shown in the bar graph. Find the probability that a randomly chosen student in this history class received a C or better. So we want to find the probability that a randomly selected student or chosen student received a C or better. So what we need to do is we need to identify the total number of students or trials that have actually taken place. So the total number of students, if you look at this bar graph, what you're going to see are these little numbers on top. And these little numbers on top represents the frequency of each letter occurring. So if you were to add 3 students earning an F plus 1 student earning a D plus 8 students earning a C plus 12 students earning a B plus 7 students earning an A, that is a total of 31 students. So we found our total of students, and now we want to figure out, of those surveyed, how many of them received at least a C. So at least a C means they earned a C, a B, or an A. So you know that whenever we see the word or, we're going to be adding all of those values together. So the number of students who earned a C is 8, plus the number of students who earned a B is 12, plus the number of students who earned an A is 7, and 8 plus 12 plus 7 is 27. So 27 students received at least a C. So the probability, this P in front of a parentheses, that at least a randomly selected student earned at least a C in the test is going to be 27 out of the 31 students, which is approximately 0.87 or 87%. So 0.87, that is very likely. It's on our side of very likely to occur. If I put all of these students' names into a bag and I pulled out a name, and the chances that one of those students earned a C or higher, it's going to be that the name that I pull out is going to be a student who earned a C or higher, is going to be pretty likely. The last type of probability that we have is geometric probability. And geometric probability means that we're going to be working with geometric figures. And what is the probability of throwing a dart or throwing a ring or something to that effect and it landing on that shape? So some probabilities are found by calculating a fraction or a portion of 2 lengths, areas, or volumes. Such probabilities are called geometric probabilities. So that means that we're going to be focusing on their areas or focusing on their volumes depending on what the question is asking of you. And these types of probabilities kind of go hand in hand with the type of games that you might see besides just throwing darts. Maybe when you go to like like a fair or something to that effect, where you're trying to throw something against like balloons or a certain target, or trying to toss a ring into a certain space. Things of that nature, that's where geometric probability comes in. So we want to find the probability that a dart thrown at a rectangular board hits one of the triangles. So that's what we want to figure out. So the probability that a dart hits one of the triangles means that we are trying to figure out, we're going to be looking at the area in which we want to hit divided by our total area. So the area that we want to hit are the area of the triangles. So it's going to be the area of the triangles. So we're going to need to identify the total area of all triangles alone, divided by the total area of the rectangle. So let's go ahead and remind ourselves of what the area of a triangle is. The area of a triangle, that formula is base times height cut in half, or 1/2 base times height. Both mean the exact same thing. And the area of a rectangle, that is equivalent to base times height, or length times width. So the first thing I'm going to do is I'm going to identify what the area of my first triangle is. So my length and my width, or my base and height, are 3 and 4. So I'm going to multiply 3 times 4, and I'm going to cut it in half. And then I'm going to add it to the other triangles. So my base is 5, my height is 8, so I'll have 5 times 8 cut in half. Plus, once again, I have a 3 times 4 cut in half. I'm going to take that and divide it by my total area of my rectangle. So my total area of my rectangle is 40 times 10. That's my length times width, or my base times height. So I have 12 times 4, which is, 3 times 4, which is 12, and 12 divided by 2, which is 6, plus 5 times 8, which is 40, 40 divided by 2, which is 20, plus 3 times 4, which is 12, 12 divided by 2 is 6, all over 40 times 10, which is 400. 6 plus 20 plus 6 is 32 out of 400. And 32 divided by 400, you can put that into your calculator, or they're both, if you can recognize that they're both divisible by 16, that might be a good thing. 32 over 400, that is going to be 2 over 25. So you have a 2 in 25 chance of actually hitting the target, actually hitting one of the triangles in this figure. And that is the end of this lesson. If you have any questions over anything, please make sure that you email me. Otherwise, I hope you guys have a wonderful day.